Hey everybody, it's Mr. Carr again. Today we're going to be looking at 7.2, angles formed inside of a circle. So we have some more vocab words we want to show. We got tangent, chord, inscribed angles, and intercepted arc. So a tangent is a line that intersects a circle in exactly one point, and that point is called the point of tangency. It looks something like this. If I have a circle right there, and I can draw a line, and it hits exactly one point, that's a tangent line. Okay. A chord is a segment whose endpoints are on a circle. So if I draw a circle in and I just draw anything inside, it doesn't matter where it goes. It can go here, it can go here. Okay. As long as the endpoints are on the circle. Now, a special one is one that goes right to the middle. If I have a chord that goes right through the middle, like that, then that's a diameter, which is one we talked about before. So diameter is considered a chord as well. We got inscribed angles. We'll draw, and we'll run out of space here, but I'm going to just draw one circle here for two different things, like that. So an angle whose vertex is on a circle and whose sides contain chords of the circle. So my inscribed angle looks like this. If I draw two chords that meet, here's my inscribed angle right here. Okay, there's the vertex at this point right there. So this is my inscribed angle. Okay, write that one. The intercepted arc is the arc that lies in the interior of an inscribed angle and has endpoints on the angle. So the arc we're referring to is this one right here, like that. In fact, let me color code it a little bit. And that one right there. My intersected arc is in blue. It's talking about this because it shares the same endpoints as my inscribed angle, whereas my inscribed angle is just this angle right here. Okay, so we have a variety of properties and relationships based on that. First one is the measure of an inscribed angle. So if we look at this one, the measure of an inscribed angle is half the measure of its intercepted arc. So when I look at this one right here, here's my arc and here's my angle. So the measure of angle ADB is equal to one half the measure of arc AB. Okay. Or if we want to go the other way with it, so basically if I go, for example, if I go from here to here, I multiply by half. But if I go the other direction, I take the angle and I go here, I can double it. So if I can say that 2 times the measure of angle ADB is equal to the measure of arc AB. That's just a matter of because like making sure you understand which direction to go with that. So when I look at the next one, I want to find the measure of angle S. So angle S is right here. It is an inscribed angle with this arc of 60 degrees. So again, the angle is half the arc. So that means the measure of angle S is equal to one half of 60, which means the measure of angle S is equal to 30 degrees. Okay. When I want to find RQ, so this one's got a couple of steps going on with it, but here's RQ right there. Well, what's going to be helpful is if I first know what this arc is going from Q to S. And just like we do over here, we double an angle to get to its intercepted arc. So I can take 37 times 2 to get 74 degrees. The other important part about this is the fact that since P is my center, this is a diameter. Or sorry, this is a semicircle because this is a diameter here. Meaning RQS, the whole thing is 180 degrees. So now to find my measure of arc RQ, that's going to be equal to 180 minus 74, which is equal to 106 degrees. Okay. Inscribed angles, same intercepted arc. If two inscribed angles of a circle intercept the same arc, then the angles are congruent. Okay, so we're looking at something like this. It should be pretty straightforward. It makes sense that if I have this one right here, that's 39 degrees. If I were to double that, that would give me 68 degrees. But then I have this one right here, which is also an intercepted inscribed angle with that same intercepted arc. So it's half of that one. So we just take half again. Oh, that's not, it's 78 degrees, sorry. So this would be 78 degrees, and then half of that would be 39 degrees again. So that's how we know that the measure of HGJ and H, oh, sorry. sorry, my bad. We want to find the measure of HGJ and arc HJ. So I'm going to start with actually the arc here. So I take the measure of arc HJ is equal to 2 times 39, which gives me 78 degrees. And then the measure, go black on that one, the measure of angle HGJ is equal to 1/2 78, which gives me 39 degrees. And again, we're just trying to demonstrate that if they intercept the same one, they have to be congruent to each other. So I could have just done a shortcut instead of having to double and then half again. I just know that these two have to be congruent is the idea. Okay. All right. So we have intersection of a tangent and a chord. So if a tangent and a chord intersect at a point on a circle, so here's my tangent, here's my chord, here's the point that they're crossing at, then the measure of each angle formed is half the measure of its intercepted arc. So what I mean by that is, let me scroll down. This angle 1 here. So the angle between like that, the intercepted arc is this one right here, going from A to B. The endpoints are right here and right here of that arc. So that means that the measure of angle 1 is equal to 1/2 the measure of arc AB. Okay. Additionally, if I go over here and I look at angle 2, well, that is intercepting this arc, the major arc there. So it works that direction as well. The measure of angle 2 is equal to 1/2 the measure of arc ACB. Okay. So you can do either one. So it's just, again, that in that angle right there is half of that arc is the idea. Okay. So when I do this one, the measure line M is tangent, find the indicated measure. So if this is 132 degrees, that is going to be the arc. So 132 is arc AB. So that means the measure of angle 1, it is half of that arc. So the measure of angle 1 is 66 degrees. Okay. When I want to find EFD, so that's right here, that is related to the 110. So I can do the measure of angle. The measure of arc EFD is equal to 2 times 110. So the measure of arc EFD is equal to 220 degrees. That's it on that one. Okay. Next one, intersection of a tangent and radius. So in a plane, a line is tangent to a circle if and only if the line is perpendicular to a radius or diameter of the circle at its endpoint on the circle. So we're basically just saying that tangent lines are always going to be perpendicular to a radius or a diameter if I draw it all the way out. That's it. Now, think about where we've seen perpendicular lines like that. You'll see it a lot with these types of things. When we try to find our, we try to, like in this case, we're going to confirm it or use this information along with our right triangles, meaning we are going to do some Pythagorean theorem. So for example, RS is a radius. Is ST tangent to the circle R? So the idea is that if ST is tangent, this has to be a right angle. If that's a right angle, then that's a right triangle. So really, this question boils down to, is it a right triangle? Okay, so to confirm that, we're going to do the a squared plus b squared equals c squared. Does 10 squared plus 24 squared equal to 26 squared? So that's 100 plus 576 equals 676. So 676 equals 676. So the answer is yes. Since this is a right triangle, that means that ST is tangent to, to circle R. Okay. The next one is a nice little challenge to it. So I'm going to talk, I'm going to set it up. Yeah, okay. So we know B is a point of tangency. So find the radius R. So we are going to set this up using like R squared. That's this one right here. This length is 49 plus R. So that's my hypotenuse of this right triangle. So we're going to do R squared plus 77 squared is equal to 49 plus R squared. You have to multiply this part out properly. So what I'm going to do is I'm going to do 49 plus R times 49 plus R, which means we're going to distribute that like that. I'm going to take a little shortcut. It's going to turn into 2,401 plus 98R plus R squared. So then I'm just going to go ahead and bring that back here. So we have R squared plus 5,929 is equal to our 2,401 plus 98r plus r squared. From here, it almost looks like I have to solve a quadratic, except when I subtract r squareds to both sides, they both cancel out. So the only other thing to do is subtract the 2401 over to 2401 to both sides. So that comes out to 3,528 equals 98r. And then I'll divide both sides by 98. So then I get 36 for r. Okay, and that's my final answer for that one. All right, last theorem for this one. If two chords intersect inside a circle, then the measure of each angle is half the sum of the measures of the arcs intercepted by the angle in its vertical angle like that. Okay, this can be a little bit confusing, but when I look at this diagram, this is what we mean here. Here's an angle inside, this angle x. Here's its vertical angle like that is also going to be angle x. Doesn't really matter which one we're looking at here. But if I look at the end points of this like x figure here, okay, we have arc 112 and arc 140. And I like to do this. I like to draw a line that goes right through both vertical angles. So I'm connecting those two arcs. So that's 112 and 140. Well, that means based on this, the measure of angle x is equal to 1/2 the sum of 112 plus 140. So the measure of angle x is equal to 1/2 of 252. So the measure of angle x is equal to 126 degrees. Okay, so let's say I also want to do this one like this angle y. So in this diagram, I'm just going to write this out. Angle x is equal to 1/2 the sum of arc fj plus gh. Okay, so if that's me going that way, with y, if I go this way, now these are my two arcs. So if I wanted to find angle y, I would do that one instead. So that means I would do the angle y is equal to 1/2 of fg, oops, that a little better, fg plus jh. Okay, so it'd be those two arcs instead. So I like to draw these lines like this. So y would be intersecting with both of those. So that is our, it just depends on which one we're looking for. We're just trying to find it based on that. Okay. Lots of circle facts today, lots of different things with angles inside. So please make sure you get the practice on these. Yeah, there's a lot going on there. So, all right. And that's it for today. Take care, everyone.